All right, welcome back. We are INFR3110, and it's in the fall 2020 semester at Ontario Tech University, and it's Game Engine Design and Implementation, Week 8, Part 2, Building an Event Manager, and the Event Pattern, which is what we want to talk about very briefly. Again, I suspect we're going to end early today, but let's talk about this. So when we think about what we want to create something called an event queue. Just the word queue in your mind should be it's a data structure, right? So, and how does this work? We want to decouple again. It's always that word: decouple, uncouple. Separate concerns, this kind of stuff. I want to decouple the message or event from when it's processed. So we have two pieces: the message is sent, the message is processed, but we don't want to put them together. When they're tightly coupled, that means that we're going to have collisions. We're going to have things happening where one message or event is colliding with something else that's happening at the same time. All right, so how does this work? So some related terms. A message queue, you're going to hear that. An event loop, you're going to hear that. Or a message pump. All these different things mean pretty much the same thing. Okay. All right, so why do we need an event system at all? To centralize all interactions. We want to keep track of events that are being passed through the system. We also want to manage communications between the logic and the views. A lot of times what we're talking about here, again, going back to what we said just before in the last video, which was this idea of a model view controller pattern. The model being the class that connects to your database, data store, network, whatever you want to call it. Your view, which is your scene. It could be what you're presenting to the player, the graphic representation, you're rendering, whatever you're rendering to the players, presented to them, right? And then your logic behind the view, the controller, right? And usually that's what the controller is, the logic behind the view. So model, view, and controller, separation of concerns. So we want some kind of messaging queue or some kind of event queue that manages messages that we send from one system to the other, from the model to the controller, from the controller to the view. Okay. There's different kinds of game events that we can go through, and I've listed some of them here. So, for example, when the actor moves, that could be a game event. A game object is moved. An actor collision. Notice it's called an actor. This could be an entity, that has some kind of rendering capability in the game. Right? Remember, there's three types of game objects or entities. We have a game object that just updates, a game object that just renders, and a game object that renders and updates. Okay, so an actor would be one of those game objects that typically renders and updates at the same time. All right. So different kinds of events that are listed here. Also different kinds of animation events. The animation started, the animation looped, the animation ended for that particular animation. The graphics, physics, other kinds of things that are listed here as well. Okay, so different kinds of events. So we can think about an event loop or a messaging system as very simple like this. We have some kind of event, and what we want to look for the event loop would just keep on getting the next event, the next event, the next event. Okay. And what happens is every time we click a button, pull down a menu, move a mouse, something that happens in a game, we're generating or triggering, sometimes it's also called raising an event. All right, we're raising some kind of action to occur. We're triggering the action, okay? Again, this all kind of connects together. All the things we've been talking about this semester, really at the end of the day. We've talked about the observer pattern and the command pattern. They connect to the event queue. Right? So here we're creating an event system, right? With the observer pattern and the command pattern and the event queue. Okay? All right. So when we call the get next event, it pulls an unprocessed user input into your app, right? And then what we want to do is we want to send it to the event handler. This is usually some kind of function or delegate. Delegate meaning some kind of anonymous function, or it could be a lambda expression, and that anonymous or named function, right, is where the action happens. Okay, And the interesting part is that the application pulls in the event when it wants it. So again, this goes back to the whole subscriber and publisher structure that we talked about with the observer pattern. All right, so how does it work? Well, we have our operating system. We click something, we get an input from a device, and we're going to be talking about human interface devices next week. And when we click on something, we maybe we click or we push up or down or shift or something, then we get the next event. All right, so we input the stuff into the event queue, and then we get the next event and the next event and the next event. So what's happening is we have something called a central event bus, right, where things are happening, where we're getting input, physical input from the system, right? Let's suppose I want to make a tutorial system like you guys are making for your assignment number 2, right? And you want to display help boxes after specific in-game events occur. Let's suppose you're training the user on how to use the combat system as an example. I just did a little video with Borderlands, and they talked about how to use the combat system, how to shoot things and how to do certain things in the game. Your gameplay and your combat code is pretty complex as it is. The last thing you need is you want to do all this extra triggering stuff that's happening in the combat code. You want a separation of concerns. What you're looking for is something called a central event queue, or a central event bus, or a central messaging system, right? Whatever you want to call it. And it might look like this. So the queue itself, when the combat system sends a message, example, I hit something, right? Or I got hit by something, or whatever is related to combat, it puts that message, that log, on the combat queue, or sorry, in the queue, the event queue. At the same time, the tutorial is also going to say that yes, this part of the quest system or tutorial system that we're using has been completed. Let's put that on the message queue as well, right? So what happens is these two things are put on the message queue. Neither of them by default are prioritized. And then at the other end, what ends up happening is we can inform whether the combat system itself, that the tutorial is taking us to the next level, or that that combat action has been executed and the tutorial has that item on the tutorial has been satisfied. Okay, but it all goes through a central messaging bus. Notice that those words are all interchangeable. So then a queue is what stores, this is the pattern, a queue stores a series of notifications or requests in a first in, first out order. It's a queue. Sending a notification on queues the request and returns, right? And the request processor then processes items from the queue at a later time. Okay, so what happens is we dequeue, something from the queue, the event queue itself. Okay. Requests can be handled directly or routed to registered parties. Registered parties meaning the event handler, right? Or some kind of anonymous function or lambda expression. Okay. And what this does is it decouples the sender from the receiver. The sender is sending messages. It sends messages to the people that care, again, thinking about the observer pattern, right? We have the observable, something that's going to change, potentially. We have the observer, the thing that's registered, as an example. And then we have the actual publisher. And the publisher is going to publish an event that the observer subscribes to, right? And then we're going to have the subject perform that event. Okay, that's what's happening. So this decoupling, again, it all links together. Okay, it all links together, and the decoupling links together. Wow. It all links together. All these patterns are connected, is what I'm trying to say. All right, so let's talk about a popular way of doing a queue. One popular way is creating something called a ring buffer. All right, and again, whenever I hear the word buffer, I always think about array, right? An array of data, whatever that array is. All right. Why is it called a ring buffer? Well, you have a head and the tail of the array, and think about the tail of the array as an example as just past the end of the queue. Okay, that's what happens. And so what happens is all the newer events are coming in here, all the older events are coming in here. When we unqueue an event, it moves the pointer to the tail from the tail one step to the right. Okay? When we dequeue an event, it takes the head and moves it also one step to the right. Okay, so now the head is pointing to the next, whatever the next first element is. The element that was at the head has been dequeued, has been removed from the queue altogether. Either removed and destroyed or removed and reused. Okay, so that's how, kind of a head and tail is. But the problem is that eventually we're going to, potentially run into spaces, as an example, that might crash into some kind of memory location we don't want to get into if we did it this way, right, with an array. So what's the solution? Again, we might have something that looks like this. So these are all the available spaces. We've just freed up this space because we've moved the head of the array over because we've dequeued. We've emptied some part of the array. And here we don't have available spaces anymore. Here it's like new memory. We don't want to allocate any new memory. So how do we do that? We create a circular array of cells. And this circular array of cells is the ring buffer. So we kind of go back to the beginning. We kind of move our array, or the cells, around, so we have a continuous buffer. This is one way of doing it. The other way of doing this is with some basic data structures. And by the way, all the languages, modern languages, have their own queue class. So for example, C# has its own queue class, Java has its own queue class, and even modern C++ and we're using the STL has its own queue class. So you don't have to create your own if you don't really want to. Now, why would you want to create your own and make it an array and not a queue structure? Speed. Some people complain that the standard template library that's built into C++ is just a little bit slower, and it's got a lot of functionality that maybe you don't need. But to me, emplace, which is like onQueue, and pop, which is like dequeue, is perfectly fine. I would totally be happy with using something like this, at least as an initial data structure to get going with an event queue. All right, so that is that's taken us up to about 4 o'clock. Like I said, this is where the stuff that I wanted to talk about with you today ends. From now until the end, what I really want to talk about is a couple things. For next week, I want to be talking about human interface devices, but there's going to be a talk that we're going to do on data-oriented design. And I've been waiting this long to talk about data-oriented design and dots because I wanted you guys to have a sense of, or at least discuss, ECS with you. So before we get into dots or data-oriented design, DODS, let's take a look at this for a second and see what this is. This little tutorial, if you will, I'm not sure if it's a tutorial, but it's really a foundational tutorial. It's about 30 minutes. It takes you to read through it from Unity Technologies, and it really talks about dots and why it's important. Okay, so I'd like you as homework to take a read. I know some of you may like not to do this, but remember, this is going to help you when it comes to understanding what dots is. It's a pretty quick read, in my opinion, if you kind of skip through it. There's other related information here that is super important, I think, from a modern game engine perspective, because we want to understand dots. By the way, the people at Ubisoft that we were talking about yesterday about dots, there were like one guy that was saying things like, dots is really popular, but I want to talk about what makes dots so good compared to object-oriented programming. Why not just use object-oriented programming and ECS as opposed to data-oriented design, right? And really what Unity is saying is that you really can't take advantage of data-oriented design or ECS, because they do use kind of an ECS in their architecture, but really what they say is for you to take advantage of a true ECS with Unity, you want to use data-oriented design, the new dot system that they've kind of built in. It's optional, obviously. You don't have to do it. And there's 3 pieces to it. There is the entity component system. That's one piece that they have there. There's something called the C# job system and the burst compiler. And these 3 pieces, these 3 pillars, if you will, of dots, is the way that ECS and data-oriented design works for Unity. So please take a look at this article. I'd like you to kind of look through it. There's also some other additional links about what this all is about, and I think it's some good reading for you guys and good, I would say, enrichment when it comes to what this is, how it can help us build better game engines, and how we can take advantage of it even in Unity. Right now, I'll have to tell you, even if you watch any of this stuff, that compared to the way Unity works by default, I would say that dots is more complex. All right. In fact, a lot of the stuff we see when it comes to entity component system, if you're going to dig into the weeds like this, is more complex. It looks completely different than what we're used to right now when we're using Unity. So again, take a look at this. I'm going to cover data-oriented design in another class, but I want you guys to have the context, right, by reading through this tutorial right here. And I think it's great for you guys to understand what this is. All right, so that's your homework for today. Any questions at all about the stuff that we've covered today? So we've talked about, wow, look at this. We've talked about a bunch of stuff. We've talked about, you know, the first part, which was about the components, and we talked about, you know, how we have contiguous memory and how that can help us. We talked about RAM, and now we also talked about this idea of an event queue and how we can use that. By the way, the event queue idea, right, or a message queue, that's used all over the place. That's even used by microservices up online. If you're a web person, right? So microservices uses an event queue as well. And for those people who don't know, let's take a look at, if I looked up what microservices is, and I'll stop here, I swear. I'm just looking that up for you guys so you can see it. So if I look at microservices, and here I'm just going to pull this in, a lot of times what we have is, it's a pattern, right? So I have a big monolithic application, and instead of having a massive monolithic application, I break it down into little pieces called microservices. A login service, some kind of you know, shopping service, a shopping cart service, or whatever you want, right? How do these pieces, why would you break it down? Well, they're reusable. I can plug in these microservices into anything I want, right? Into other websites and web applications. Fantastic. But what about communications? How do they communicate with each other? An event queue, right? This is the kind of stuff that we've been talking about today. We use an event queue to communicate from one microservice to the other. And each of the messages in the queue are secure. And they're guarded by something like JWT, some kind of JavaScript or, JSON Web Token. And the JSON Web Token is a thing that has all the information about security that's being sent from one microservice to the other. And you're going to learn more about distributed networking next semester. But the idea of an event queue is something that you're going to see again and again. It's not the last time we're going to be talking about it. At least not in your software engineering career. Okay, any questions for me before we stop for the day? I just wanted to talk about that kind of stuff. I also wanted just to circle back before we finish the day on, again, where we are and what's due. Again, just a reminder that we're sitting at week 8, right? It looks like group assignment 2, part 2 is not due next week, but the week after. Now there's things that I've asked you to do for part 2, so please, I'm not going to talk about necessarily much more about part 2 today, but what I will talk about today is anything that's part 1 related that's due this week, okay? And then next week we're covering human interface devices, and the last few lectures after next week, notice is gameplay systems. We're going to do another checkpoint coming up in a couple weeks, right, to see where you're at. Post-processing and shaders for Unity, we're going to be talking about that, and we're going to finish off with your final project presentations on week 12. All right, and then we're right into exam week. So it's not that far away. We're kind of, I would say, 2/3 now through the semester. Any questions at all before we end for the day? If you do have a question, you can put up your hand in the participants panel. For now, I'm going to stop recording. Okay, guys, I'm not recording anymore.